Hi everybody, I'm Jean-Christophe SAKDAVONG from the University of Toulouse. I'm researcher in the CLLE Laboratory, which is a cognitive psychology and ergonomics lab, and I'm doing most of my researches about virtual reality and education, and also about video games ergonomics. Today, my presentation will be about the main factors to improve education through mixed reality. I will review results from researches in cognitive psychology. At the end of my presentation, if some arguments were not enough understandable, please do not hesitate to ask me questions. My presentation will be the following. First, I will try to define mixed reality and learning. Then, I will talk about the common factors which are impacting learning. These factors have been deeply studied by researchers. Then, I will talk about specific factors to mixed reality. These factors are quite new and not always enough studied. I will conclude by some guidelines for e-learning mixed reality designers. I will now define what I have called mixed reality and learning. Mixed reality is a domain which includes virtual reality and augmented reality. It goes from camera-enabled smartphones to augmented reality glasses such as Microsoft HoloLens or to classic virtual reality headsets. This is the Virtuality Continuum from Milgram and Cognition. As you can see, on the left, you have a real environment that you can enrich with augmented reality elements. It is to say, information, 3D objects, which are not real. It can be information or virtual elements. Then, if you watch this picture from the right to the left now, you can see virtual environment as you can imagine it with a head-mounted headset, so the usual virtuality, in which virtual environment you can add real elements such as photos, videos from reality. And now if you join the two parts of this graphics, you can understand that you have a continuum going from the reality that you can augment with information, and then you have the center part, and then you have virtual environment which are enriched with real elements and going to fully virtual environment. This is what we call the virtuality continuum. The mixed reality is in the middle of this graphics, the mixed reality as I call it. I will use this graphics as my reference in the following speech, and I will reuse it to show you a few dimensions, interesting dimensions. I will now provide an overview of the generic factors impacting learning with technology and with mixed reality according to cognitive psychology. Here you can see a representation of the human memory system. You can see the two parts with long-term memory, short-term memory, and I have emphasized the three parts which are the most interesting for us. The usual knowledge, which are part of the semantic memory, which is a part of the declarative memory. It can be, for example, knowledge about grammar structure for pupils, knowledge about geography for high school students, or knowledge about blood for nurses or physicians. The second interesting part is about the skills, which can be motor or cognitive. They are a part of the procedural memory, which is part of the non-declarative memory. Skills can be about airplane maintenance procedures for aviation technicians. It can be skills about driving for driving school students, for example. So these two parts are interesting us a lot because it is most of the knowledge we would like to transmit thanks to mixed reality. And it is important to understand the nature of it. Then there is a third part I have emphasized, which is about classical conditioning, which is used, for example, by psychologists to help to fight against phobia or traumatism. For example, they use it to fight against fear of spiders or fear to speak in public, which you can neutralize by new conditioning. Now that we have seen these three parts, I will speak about the working memory. We all have a working memory, and this working memory has a capacity that you should not overload. According to Sweller and al., this is the structure of a working memory. While you are learning something, the first part is the intrinsic load. This part is bound to the learning task itself. For example, if you are learning how to control an airplane part for a technician, or if you are learning how to install an infusion for a nurse. This is the most important part, but we usually don't know that there are two other parts which can overload the working memory. The extraneous load is connected to all the things which are not really the intrinsic load. For example, understanding the human-computer interface. If you are in VR, understanding the many functionalities of the controllers. But it could be if you are making a learning task with mental maps that you have to build. The learners may not be used to build this kind of maps, and this will use a part of their cognitive load. This part will be an extraneous load. So, to have good learning, we must take care about having the lowest possible extraneous load. And then there's a third part that most of the people do not know, which is called the germane load, and which is used by our brain to build mental schemes, to build the knowledge. This is allowing the learning. And if there is no space, if there is no load for this German load, you will not learn. As we tell in French, it will enter by one ear and exit by the other one. So it's worthless. It is very important to take care of this structure of the memory. You can see here an example of a good learning where the working memory is not overloaded, and another example with a bad learning where the extraneous load is too high, and so there is no way to learn because the working memory is overloaded. I will use this example to tell you a few words about a debate that cognitive psychology researchers have currently about learning and VR. I have made a study with VR Museum where I have found that learners are learning better if they are active in the VR environment, if they decide where they go, if they decide what to see and watch. But there is another research which is showing that when the users are active in VR, because there are a lot of stimuli, then the extraneous load is high and the long-term memory learning is worst. So we need further investigations to understand what it is really happening, in which cases, and that's why we should not trust only intuition about the subject, but really follow what the research are telling us and what they will tell us in the future. In order to respect the working memory, Puma and Tricot in their researches have shown that there are 4 points to take care a lot. First one is the learning task in order not to overload the working memory. Then the learning materials are quite important because they may overload the extraneous memory. Then you have to take into account the learner's expertise, because if the learner is a beginner about a subject, your learning task has to be smaller. And if the learner is a beginner, not about the learning, but about the learning topic, but about the way you are learning, then the extraneous load may be too high. And finally, the fourth point is the time. If you let more time, if you allow the learner to have pauses, then it can learn better because it will lower the cognitive load. That's why adaptive learning may be a way to solve the working memory problems. If we apply this to VR or mixed reality controllers or hand recognition, it's important to make the controls very intuitive and common with the other application that users knows. It is really important not to make complex combinations of buttons or sticks. Or, if you have to do it, you have to build pre-training sessions. It's also important to use common control strategies as Android or iOS are doing for mobile design. If you are making augmented reality, this is interesting because it can lower the extraneous load, taking advantage of real-world objects, which are more intuitive. There is also another way to lower the working memory load. You can use the 2 channels that Badley has shown, which are not using the same working memory resources. It is from one side the visual spatial sketchpad and from the other side the phonological loop, which means that you can put an audio and something written or a graphics at the same time, and it will not use the same resources. It will not be added in the working memory load. This is really important to use this. And at the opposite, it is important to avoid to have for the same channel different sources of attention. For example, it is obvious that you never have 2 speakers at the same time. But it is less obvious, and you can see it often in learning website documents, that you have nearby a text and a video, which are using the same channel. So for VR, we can, for example, have at the same time an avatar talking with you and observe some phenomena. This will be quite effective. For mixed reality, we have another challenge because we have spatial sound and the user can move near one source or another one. This is really a new challenge because it has not yet been studied, and it may be quite useful to lower the working memory and to make new ways of learning, letting the user active in choosing which source you want to use. The Meyer principles and the theory of multimedia learning are really interesting for mixed reality. Meyer has proposed 12 principles, and I have selected 3 of them for us. The first one is matching with the previous slide, and it's telling us that people learn better from graphics and narration than from graphics, narration, and on-screen tests. The second one is the spatial contiguity principle, and we should really use it in virtual reality, where we can superimpose real elements, virtual elements, words, pictures, and put them very near. This will be an important principle. And the third one is the temporal contiguity principle. People really learn better where corresponding words and pictures are presented simultaneously rather than successively. And we can really do this in virtual reality, in augmented reality, easily. I will now present you some scientific results about working memory and virtual reality and augmented reality. First of them, a study from Barong and Meyer about how the cells in the human bloodstream work in VR has shown that the VR may increase cognitive load. So it's important to make pauses and summaries in your virtual reality learning materials. Billinghurst and Wenzer have made a meta-analysis about augmented reality instructional designs, and what of their main findings are that augmented reality supports the understanding of complex phenomena. It's really helpful for spatial and temporal concepts. It's helping to emphasize the relationship between the real and the virtual object and really provide an intuitive interaction. So it's really important to use it when you do augmented reality designs. Another meta-analysis from Santos and al. Shows us important things about augmented reality and mixed reality. When you augment reality, you can make real-world annotation. You can make visualization with contextual information. With embodied interaction, you can do visual haptic visualization. And you can extend the multimedia theory by replacing pictures by real objects. Real objects are displayed in the augmented reality, either through the screen or holograms. So you can really continue to use the spatial and contiguity principle. Another result that they have found is that people learn better because they are creating meaning from their personal experience, and this is really better for learning. Another meta-analysis from Radu emphasized on the fact that augmented reality and mixed reality are really improving the learning of spatial structure and how it works. It's really good when you have physical activity, and one of the study was about tank repair and maintenance. It's good for long-term memory, it's improving collaboration and motivation. But you have to take care about attention. The tunneling effect may decrease the performance. The cognitive tunneling effect is when you focus too much on one point and forget the other ones. For example, a plane pilot who is too much focused on the head-mounted display information and who forget to watch through the windows of the plane. I will end this enumeration of scientific results by Radu's one, which is proving that augmented reality and mixed reality really help to understand spatially complex or invisible elements. For example, in their experiment, they were studying magnetic forces in speakers, displaying them with augmented reality, which has helped a lot students to understand these invisible forces. So we should use this. I will now tell you a few words about mixed reality specific factors. I'll visit again the Virtuality Continuum with the idea of learning. You can see at the left the real learning environment and at the right the virtual learning environment. And we are having our journey from this real learning environment to the virtual learning environment. The mixed reality for learning space is in between these two ones. The augmentation will be the digital information helping to learn or to understand the material. And we are searching how to make it easier. If we have a look at the implementation, we can see that augmented reality can be implemented by augmented reality headsets with 6 degrees of freedom and controllers with also 6 degrees of freedom or hands recognition. And another way to do it can be a simple tablet, smartphone with an integrated camera, and then you have 3 or 6 degrees of freedom. And if we go to the right, we can have the virtual environment in a virtual reality headset or in a simple computer screen. I will now talk about two objective technical dimensions. I call them objective because they are not dependent on the subject. They are dependent on the implementation. On this slide, it will be about the control and interaction, and on the next one, it will be about immersion. There are not many studies about the effect of control interaction with the learning environment and the effectiveness of the learning. So it's really a work in progress. What I have shown on this paper from 2019 is that the more the user, the learner is interacting, is active, the more he is learning. Now it's really to find out which kind of interaction are helping and not overloading the working memory. The interaction can be about moving, it can be about the controllers, it can be, if you are with a tablet and an integrated camera, about turning around the object that you are augmenting. So that's, again, a very interesting challenge, but we don't have any definitive answer. The other objective technical dimension is immersion. It's again completely dependent on the implementation. It is obvious that with a head-mounted device, a virtual reality headset, you are completely immersed. With augmented reality glasses, such as Microsoft HoloLens, you are not completely immersed. With a small screen, it's less than with a very big wide screen. In her studies, Muhana has shown that immersion and also control are improving learning. But in a study that I've made with my colleagues, Nathalie Huet and Morgan Burtz, we haven't found any result comparing a learning with tablet and a learning with virtual reality headset. So it needs more studies to be sure that there is really an effect. Of course, intuition tells us that it does, but it's not so sure, and it's absolutely not proven yet. I will now speak about a subjective variable, which is quite important and that a lot of researchers are confusing with the immersion one. The immersion is completely dependent of the implementation. The presence is depending on the subject. Presence is much more than immersion and can be very different from one learner to another one. To feel present is to have the sense of being in a world generated by the computer instead of just using a computer. You feel you are there. This feeling of presence is influences performance, training, engagement, and motivation. So it's quite an important variable, and you really have to check it by studying with your learning device and participants. So it needs a study in order to know if you are really bringing this feeling of presence. You can split the presence into 3 dimensions: the spatial presence, the social presence, and the self presence. And the 3 ones are important. In the self presence dimension, you can encounter the embodiment, where the avatar can be important, and also it's important to choose between first and third person, as Breche has shown. If the learner can see his body, then the episodic memory will work better. So it's quite important to take care about it, especially if you are working also on spatial memory. Embodied cognition can be a key in learning with mixed reality. The main difference between the usual cognitivism and embodied cognition is that in the first one, the human is seen as a computer with a main processor in his head. And with embodied cognition, we think that humans use their sensory neutral structure to create multisensory representation of their environment. The whole body is used to learn and think and retrieve information from memory. So, motor system, perceptual systems are important and participate actively to the encoding and recall processes. What we can try to remember is that reuse of motor or perception can make learning easier, and this is really easy to do with mixed and virtual reality. Now I will try to give you some guidelines for e-learning mixed reality designers. So, what should we remember? Mixing vocal and visual channels, lower physical distance between the concept, for example, between the real elements and the augmented elements in an augmented reality learning. Take care about the cognitive load when we design VR learning sessions and make them the most intuitive we can, especially about the interactions. This will lower the extrinsic load. Make pauses and summaries between the learning steps. Increase the feeling of presence as it's helping the learning. Make the learner active as much as you can, and use embodied cognition when it's adapted to the learning. Even if mixed reality is not new, there are not so many scientific results about it. The important now is to remember to follow future researches, watching about immersion, presence, cognitive load, embodiment, realism and abstraction also, and diegeticity. If you have any questions,